Okay, so today we're going to discuss how to balance nuclear equations. So what you need to remember is what an isotope and what a particle means. So, for example, this top number right here, this is your mass number. And that's also what it means as a particle. It's the mass number. Now the bottom number on the isotope, this stands for the atomic number, which is what you're going to find on the periodic table. And a particle, this number is the charge of the particle. So if you're dealing with an electron has a -1 charge, so it's a -1. If it's a neutron, the charge is a 0, so that's why it would be a 0 down there on the particle. So remember, when you balance, you have to make sure the mass and the atomic numbers are the same on both sides of the equation. So for this example right here, we've got phosphorus 31 has an atomic number of 15, and an alpha is going to be decayed, or you can call it emission, and we need to find out what the other particle is. So we're just going to add up our atomic numbers. 4 plus what makes 31? That would be 27. And then what plus 2 makes 15? That would be 13. So then when you look on your periodic table for atomic number 13, it's going to be aluminum. So now you just write down aluminum's symbol. Let's try another one. Okay, here we've got another nuclear equation. This one has more items in it, so let's just make sure that both sides add up. So on the product side, we've got 121 plus 1, that equals 122. On the reactant side, 121 plus what makes 122? That would be 1. Then on your atomic numbers, you've got 52 plus 0. Over here, 51 plus what makes 52? That's another 1. So which particle has a mass of 1 and a charge of 1? That would be a proton, so you would just write a P right there. Okay, now what if we go from a word to a formula? So this example right here says beta decay of ES-253. So whenever you see a particle and then you see the words decay or emission following that particle's word, this means this beta is going to be on the product side. So we're going to start with our ES-253. Oops. Sorry. Just erase that. Okay, then we're going to look on our periodic table to find the atomic number of ES, which is 99. So right here, our 99 is right there. And then since it says beta decay, we know that the beta is on the product side. So we're going to go ahead and write down a beta. So beta is an electron. It's just another name for electron. So mass of 0 and a charge of -1. And then you can either write the E symbol or you can write this beta symbol. It doesn't matter which one. And then we know that we need to solve whatever else is on this side. So 0 plus what makes 253? That would be 253. And then on this one, we have a -1 plus what makes 99. So you kind of have to be careful on electrons because they get tricky. So if we do a little algebraic equation, if we go -1 plus x equals 99, we have to add 1 to both sides. So x is going to equal 100 because of that lovely negative right there. So this is going to be 100. So now go back to your periodic table. Which element has an atomic number of 100? And that is going to be your lovely fermium, Fm, right there. So now we're just going to write down Fm. And this would be your final answer. Okay, let's try another one. let's do PM 142 undergoes electron capture. Okay, so first of all, we're going to start out with our PM 142. So our mass is 142. PM on the periodic table is element 61. Okay, and then it says electron capture. So whenever you see the words capture or bombardment, that means that you're going to add it to the reactant side, the left side. So we're going to go ahead and add an electron to that left side, and then go ahead and solve for the product side. So right here, 142 plus 0 equals 142. 61 minus a -1, okay, remember this is tricky, is going to be 60. So the element for 60 is Nd, and that would be your nuclear equation for that example. Let's do another one. Just give me a second. While I'm erasing, how are you guys? I miss having you in class. I would much rather be teaching you in person than not. Okay, let's look at this problem right here. Hopefully you guys can kind of see that. Okay. Okay, so technetium-97 is produced by bombarding molybdenum, that's a hard word to say, 96 with a deuterium, which is hydrogen 2 nucleus. What other particle is created? Okay, well, let's kind of break this down. So first of all, we know that technetium is produced. So that means it's going to be on the product side. Let's go ahead and draw our arrow. Okay. Technetium is 97 for the mass. That's what it's saying right there. And then the atomic number is 43. And the nuclear symbol is Tc. Okay. Then it says it's produced because it's bombarded with molybdenum 96. So we're going to go ahead and put MO 96. The atomic number for that is 42. And it says that that's bombarded with a deuteron, which is a hydrogen 2 nucleus. So we have a 2 for our mass number. Our atomic number for hydrogen is 1. Okay, so now we have what's on our reactant side. Let's go ahead and figure out what we need on our product side, because it says what other particle is created. So now what we're going to do is just add up. So 96 plus 2 equals 98. Over here, 97 plus what makes 98? That would be a 1. And then we have 42 plus 1, which equals 43. This equals 43 already. So 43 plus what makes 43? A 0. Now think about this. What has a mass number of 1 and a charge of 0? That particle would be the neutron. And remember, there's a list of particles in your book on page, let me check, on page 93, table 4.4. So double check and make sure you're okay with those particles and you know what the nuclear symbol is. Okay, I hope that helps. If you have any other questions, please feel free to email me, and I will be sending out more videos. Thanks, bye.